There's something happening inside the moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, the moon is made up of layers: a crust, mantle, and core. However, the moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the moon itself. It's surrounded by a hard, rocky mantle. But it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the moon's gravity as they go. It's like they were feeling the moon's invisible pull in different places. If the moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the moon, even if they can't actually go there. And the spacecraft intentionally crashed into the moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years? That's some million-dollar questions. The moon's core generates heat just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the moon itself, it also tells us more about other celestial bodies. If the moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the moon. Recently, we found some awesome stuff beneath the surface – massive caves hidden for millions of years. For over 50 years, scientists have suspected that the moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the Moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquillitatis, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now, they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure. There's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up. This is a typical crater on the moon. It's here because, once upon a time, an asteroid crashed right into it. Yep, a lunar crater forms when an asteroid, meteoroid, or a comet slams into the moon's surface. And as you can see, it's happened a lot. But one crater formed in a very different way. But then, how did it form? Well, let's rewind a bit. There's a widely accepted hypothesis that the moon itself is a product of collision, just like all these craters. But that collision was way tougher. It happened over 4.5 billion years ago when a huge Mars-sized planet called Theia crashed into Earth. That event threw a bunch of debris into orbit. Eventually, it came together to form the moon. Now, for a while after that, the moon was basically a giant ball of lava. But because the early moon was very close to Earth, our planet's gravity kept squeezing it, making it even hotter. In the end, though, the moon drifted farther away, cooled down, and formed a rocky crust. Now, moving on, about 4.3 billion years ago, an asteroid the size of a small country, like Nepal, way bigger than the one that wiped out the dinosaurs, slammed into the moon's far side. It left an enormous crater called the South Pole Aitken Basin. It's up to 5 miles deep and about 1,500 miles wide. For comparison, that's roughly the distance from New York to Dallas and deep enough to swallow Mount Everest. Now, scientists think that impact may have dug up and scattered some ancient stuff from deep inside the moon. A mixture of materials nicknamed creep, short for potassium, rare earth elements, and phosphorus. It's like a chemical time capsule from when the moon was still a lava ocean. Now, you want to know the reason why this area could be even more scientifically interesting than we realized? You see, until recently, researchers believed the asteroid came from the south, slamming upward and spreading a bunch of radioactive material, that very creep, around the crater's northern rim. But after looking closer, scientists realized the impact actually came from the north, which means all that valuable creep ended up on the southern edge instead. And guess what? NASA's Artemis 3 mission happens to be targeting that exact southern region. Researchers started questioning the old southern impact theory when they compared the moon's crater with others across the solar system, mainly Mars's Hellas Basin and Pluto's Sputnik Basin. Here they are. See? All three have this bizarre teardrop or avocado shape, wide on one side and pointy on the other. And exactly that pointy end usually shows which direction the asteroid came from. In the case of the South Pole Aitken Basin, that means the asteroid hit from the north, not from the south. To confirm it, scientists dug into old data from NASA's Lunar Prospector mission. It orbited the moon in 1998 to 1999. That spacecraft measured radioactive elements on the surface and found high concentrations of thorium, a key part of creep, around the basin's southwestern rim. Now, the Artemis 3 mission is NASA's big plan to put humans back on the moon for the first time since 1972. If everything goes according to schedule, the launch is set for mid-2027, right after Artemis 2 wraps up. See, Artemis 2, which is supposed to launch before April 2026, will be sort of a dress rehearsal. Astronauts will orbit the moon without landing, just to make sure that all the systems work smoothly, a cosmic test drive. Artemis 3 is where things are going to get real. The astronauts are expected to land near the moon's south pole, in one of 9 possible locations NASA has scouted out. The only problem is timing. Artemis 3 has already been delayed a few times, and so has Artemis 2. Artemis 1 launched in 2022. It was an uncrewed test flight that went around the moon and came back just fine. So, next up is Artemis 2, which will take real astronauts further into space. Then comes Artemis 3, the big one. Astronauts are supposed to hang out on the lunar surface for about a week doing sciencey stuff before heading home. After that, Artemis 4 and 5 will build and expand a new mini space station orbiting the moon. It's called Gateway. Think of it as a pit stop in space. Astronauts can dock there, live for short missions, do experiments, and prepare for landings. NASA's building it with help from the European Space Agency, Japan, and a few others. The astronauts are going to travel in the Orion spacecraft, launched by NASA's Space Launch System, a massive rocket taller than the Statue of Liberty and strong enough to fling people to the moon. To actually land, they'll use the Human Landing System. SpaceX's Starship is supposed to take the first cruise down to the moon's surface once it proves it can land safely. In the long run, NASA's not going to stop at the moon. The big goal is Moon to Mars. Hopefully, we can use everything we learned from Artemis to build a lunar base and eventually send humans all the way to Mars. And who knows? Maybe when people land on the moon, they'll be able to figure out another unsolved mystery: flickers, glows, or beams of light that sometimes illuminate our satellite. Let's dig deeper into this mystery, shall we? On the night of April 19, 1787, astronomer William Herschel spotted something weird: a bright light glowing on the dark part of the new moon. It shone for hours and was almost as bright as the Orion Nebula. What he saw probably was what scientists now call a transient lunar phenomenon, or TLP. Basically, quick little flashes or color changes on the moon's surface. TLPs can look like glowing patches, reddish or purple spots, or even hazy clouds that suddenly appear and fade away. Over the last 2,000 years, people have recorded around 3,000 of these strange moon flashes, using telescopes, cameras, or sometimes just their own sharp eyes. So, what's really going on up there? Well, there's no single answer. Lots of different things can cause TLPs, from meteor impacts to gas releases or even electrical activity. The length of the flash, which can last anywhere from a split second to several hours, gives scientists clues about what's behind each mysterious lunar light show. The super short flashes lasting less than a minute are most likely caused by tiny space rocks crashing into the moon. Even a meteoroid, the weight of a billiard ball, can hit the lunar surface hard enough to make it glow for a split second. The heat from the impact makes rocks shine and then quickly fade as they cool down. For a long time, scientists suspected these quick flashes were caused by meteor hits, but they couldn't prove it until the 1990s, when high-speed cameras finally became common in lunar research. Even then, it wasn't easy to confirm. Short flashes could have just been camera glitches or electric noise. The only way to be sure was to catch the same flash from 2 or more places at once. Well, that happened for the first time during the Leonid meteor shower in 1999, when scientists recorded real impact flashes on the moon. Later, we got more proof that the moon was often peppered with space rocks. While the flashes seemed to cluster in certain areas, like Oceanus Procellarum, one of the moon's big dark plains, that's likely just because of where scientists have focused their cameras. A 2024 study showed that meteoroids actually hit the moon evenly everywhere. Now, flashes that last a few minutes are probably caused by something totally different – gas leaks from inside the moon itself. Studies from 2008 and 2009 found that when gas like radon builds up under the lunar surface, it can suddenly burst out. Hey, I know how that feels. And when this radioactive gas escapes and decays, it gives off a faint glow we can see from Earth. Interestingly, those glowing spots often line up with areas where scientists have already found higher radon levels. Then, there are the long-haul lights. They stick around for hours, like the bright glow William Herschel saw back in 1787. A 2012 study suggested those could actually be caused by solar wind, a stream of charged particles coming from the sun. When that solar wind hits lunar dust, it can charge up the particles and toss them into the air, well, into space, creating massive dust clouds up to 60 miles high. These floating clouds might bend or reflect light from stars or planets nearby, making it look like the moon itself is glowing. So hopefully, we'll get the answers once the Artemis mission lands and starts its exploration. Hey, I can hardly wait.
Way out by Saturn, there's an icy moon called Enceladus. And it's literally spitting out ice into space. And that ice contains the stuff life's made of. Oh, and there's a whole ocean hiding under the ice. And who knows what's living in it. Enceladus is only about 300 miles across. It could literally fit inside the state of Colorado. But even though it's super small, it's got liquid water, energy from hydrothermal vents, and a bunch of chemicals that could actually support life. In other words, it's one of the best spots in the solar system where life could exist. Now, rewind about 20 years. NASA's Cassini spacecraft flew by Saturn and noticed something strange. Enceladus was shooting out little jets of icy particles from cracks near its south pole. Later, scientists realized those jets were coming from a giant underground ocean beneath the moon's surface. When they analyzed the frozen grains from those plumes, they found almost all the elements needed for life: carbon, hydrogen, nitrogen, oxygen, and phosphorus. Only sulfur was missing. The only problem was, most of those samples came from Saturn's E-ring, a huge ring made of dust and ice that surrounds the planet. And those particles had been sitting out there for decades, maybe centuries, meaning they could have been changed by space radiation. so no one could say for sure if those life ingredients really came from Enceladus itself. But now that's changed. A new study has just confirmed that fresh ice grains, the ones newly blasted out from Enceladus, contain organic molecules, including stuff like nitrogen and oxygen. Here's how scientists figured it out. In 2008, Cassini flew right through one of those icy geysers, and it literally got splattered with tiny particles. They hit the spacecraft's dust detector at insane speed, 11 miles per second. That's fast enough to separate all the molecules, so the team could see what they were really made of. Then the scientists used a technique called mass spectrometry and managed to study those fresh grains in detail. They found molecules that on Earth are part of certain chemical reactions. Those build the complex structures life needs to exist, including ones that may contain nitrogen and oxygen.
One of the researchers said that this likely proved that those complex organic molecules hadn't formed in space. They might have actually been coming straight from Enceladus's ocean. Another scientist explained that those molecules could play an important role in biological processes. All this means that Enceladus might really be habitable. But even if there's no life there, that's still a big deal. Because then we have the right to ask, wait, why isn't there life when all the right conditions are in place? The story doesn't end there. The European Space Agency is already planning a future mission to actually land on Enceladus, right at its south pole. They want to scoop up more samples and see what's really going on under all that ice. The launch is planned for sometime in the early 2040s, so in just a few decades, we might finally find out whether this tiny frozen moon is home to some bizarre life forms. But Enceladus isn't the only potentially habitable place we know about. Admittedly, the others are beyond the edge of our solar system. Like 3 possible super-Earth planets orbiting a nearby orange dwarf star. Now, super-Earth is just what scientists call planets that are bigger than Earth but smaller than the icy giants like Uranus and Neptune. Scientists from the University of Exeter found that those exoplanets were orbiting their parent star, HD 48498, which sits about 55 light-years away from Earth. That's practically our cosmic neighborhood. Each of these planets takes a different amount of time to go around its star. One needs 7 Earth days, another 38 days, and the last one 151 days. And the coolest thing is that the outermost planet might actually be hanging out in the star's habitable zone. That's the sweet spot where it's not too hot and not too cold for liquid water to exist. It means the planet's surface could be comfortable enough for water to exist without boiling or freezing. This makes it a great candidate for life as we know it. Over 10 years, the team collected nearly 190 super precise measurements using cutting-edge equipment that looks at the light coming from stars. By checking whether the star's light is slightly shifting toward us, this is called blue shift, or away from us, that's red shift, they can figure out if a planet is tugging on it. The host star itself is an orange dwarf, something like our Sun's smaller and calmer cousin. It's similar to the Sun in many ways, but as an orange dwarf, it gives off less radiation than our yellow dwarf star does. The coolest part is that this is one of the closest planetary systems we've ever found that hosts a super-Earth in the habitable zone around a Sun-like star. Now, super-Earths aren't exactly rare. Scientists have found over 6,000 exoplanets since the first one orbiting a Sun-like star was confirmed in 1995. To spot such distant worlds, astronomers use all sorts of tools like NASA's Kepler telescope, launched in 2009 to find Earth-like planets in the Milky Way. Let's sneak a peek at some of the most exciting exoplanets out there. Gliese 667cc is only 22 light-years away, even though that's still about 129 trillion miles from us. It's about 3.8 times the mass of Earth, and zips around its red dwarf star in just 28 days. So a year there is 13 times shorter than ours. Its red dwarf star is cooler, and the planet probably sits in the habitable zone, though occasional stellar flares could give it a sunburn. Kepler 22b is way farther out at 600 plus light-years. It was the first Kepler planet found in a habitable zone. It's about 2.4 times bigger than Earth, and we still don't know if it's rocky, liquid, or gaseous. Its orbit is close to Earth's, taking 290 days to circle its G-class star, smaller and colder than our Sun. Kepler 69c is a whopping 2,700 light-years away. This planet is almost 70% larger than Earth. Its orbit takes 242 days, putting it in a Venus-like spot in its system. But since its star is only 80% as luminous as our Sun, the conditions on that planet might be way friendlier than those on Venus. We discovered TOI 733b in 2023. This world is about 245 light-years away. It orbits its star super fast, taking just 4.9 Earth days. But the coolest thing is that it might be completely covered by a massive ocean. Could there be life in that ocean? Time will tell. GJ 1214b is 40 light-years away, pretty close by space terms. The planet is almost 3 times Earth's diameter and 8 times as heavy. It needs 38 hours to orbit its red dwarf star. The surface temperatures there hit 450 degrees Fahrenheit, and with all that heat and pressure, water behaves in crazy ways, like hot ice or superfluid water. By the way, that superfluidity is wild stuff when water moves like magic without friction. But don't try it on Earth. You'll just get dehydrated. Proxima Centauri b is the closest super-Earth, sitting at just 4 light-years away. It has a similar mass to Earth's, but a year there is only 11.2 days. Its star even wobbles a bit thanks to the planet's gravity. That's actually how scientists discovered it. The planet sits in the habitable zone but gets blasted by extreme UV radiation because it's super close to its star. Right now we can't even study its atmosphere. And finally, TOI 715b. This one orbits a red dwarf, which is smaller and cooler than our Sun. These tiny stars are pretty great for finding habitable worlds because planets can orbit close without frying. TOI 715b may have once had a super thick atmosphere like Neptune's, but it might now be losing it. Scientists need more research to see if it's now a watery, rocky world. In any case, some of these planets might have oceans, some might be way too hot, and some could even be our distant cosmic cousins. Either way, each discovery helps us understand the universe a little better. And who knows? Maybe someday we'll even set foot on one of those super-Earths.
Remember that asteroid that wiped dinosaurs off the face of the Earth? Brace yourself, we might witness a similar scenario in our lifetimes. And this time, the consequences might even be more catastrophic. There's just one tiny difference. This new asteroid is likely to smack into the Moon. No, this is not a sci-fi scenario anymore. There's this asteroid called 2024 YR4 that scientists say has about a 4% chance of hitting the Moon in 2032. So what do? Try to gently shove it off course or blow it up? A bunch of researchers, including people from NASA, dug into this and suggested several options. Their worry is real. If that rock hits the Moon, it could kick up a massive cloud of debris, and this cloud could spike to as much as 1,000 times normal levels for a few days. That's not just messy, it could endanger astronauts and satellites in low Earth orbit. One obvious idea is to nudge the asteroid so it misses the Moon. Another is a full-on breakup. Basically, a deliberate explosion. Experts use a clever term to describe it, a robust disruption. But nuking an asteroid is totally untested. Nobody has ever done it before, and it carries huge risks. You could create a bunch of smaller but more dangerous fragments, or do something unexpected that can make things worse. In any case, the idea is out there for scientists to chew on. Now here's the backstory. 2024 YR4 was first spotted on December 27, 2024, and reported to the Minor Planet Center. That's the official hub that tracks all new asteroids and comets. Pretty soon, it showed up on NASA's Century Impact Risk Table, which is like the agency's watch list for any asteroid that could potentially hit Earth. For a little while, things looked sketchy. Out of 37,000 plus known large asteroids, YR4 was the only one with a real chance of smacking into Earth anytime soon. Its odds even climbed to a record 3.1%.
That might not sound like much to such amateurs as me and you, but in space terms, that's huge. Scientists were really paying attention. Luckily, after a few more months of better tracking and sharper observations, they nailed down the asteroid's orbit more precisely. Turns out its path isn't taking it anywhere near us after all. Its chance of hitting Earth has dropped so low it's basically zero now. So, we can breathe out and relax. Earth is safe. But the moon? Maybe not. And that's why researchers are now debating whether to blow the thing up before it ever gets close. The thing is, asteroid 2024 YR4 is pretty big. Based on what the James Webb Space Telescope saw, it's about 220 feet long, roughly the size of a 20-story building. Not exactly a pebble, I'd say. At first, NASA thought there was only around a 1.7% chance that YR4 would crash into the moon. But then, the Webb telescope checked again in March, and that number jumped to 3.8% right away. By May, it climbed once again. It was already sitting at about 4.3%. In other words, the more they looked, the more likely it seemed that this space rock might actually hit our natural satellite. On the bright side, these new observations helped NASA figure out where exactly the asteroid would be on December 22, 2032, with about 20% better accuracy. Now, if the asteroid really did smash into the moon, NASA says it wouldn't mess with its orbit or make it wobble or anything dramatic like that. But, and this is a very big but a hit from something that large would kick up a ton of debris. And that flying space junk could become a real problem for satellites orbiting Earth, or even for astronauts on the International Space Station. That sounds alarming enough. That's why the story might take a turn straight out of a sci-fi movie. Scientists are seriously considering blowing the asteroid up. But unlike in a movie, this isn't about saving Earth this time. The most extreme idea is to launch a bunch of nuclear explosives at the asteroid before it reaches the moon. The thinking is, if they can blow it to pieces while it's still far away, the debris will scatter safely into space instead of causing problems near Earth. But of course, there's the catch. While scientists know roughly how big YR4 is, they don't know exactly how much it weighs. And that's a huge problem. Without knowing its mass, space agencies can't design a precise mission to knock it off course. In theory, they could send out a reconnaissance spacecraft first, something to get close to the asteroid, measure it up, and figure out the best way to push it away. But researchers say there just isn't enough time. By the time we'd collect all the needed data and build the right hardware, it'd be too late to intercept the asteroid before the 2032 impact window. So instead of a gentle space nudge, some experts suggest going full Armageddon-style, that very robust disruption. Translated into human, it's blasting the asteroid apart with nuclear explosions. Sure enough, this idea comes with a massive risk. What if the explosion accidentally changes the asteroid's path and sends some fragments toward Earth? The researchers admit it's a possibility, but still think nuking it could be the most practical solution, given the circumstances. If the mission ever happens, it would need to launch sometime between 2029 and late 2031. This would give it just enough time to reach and intercept the asteroid before it gets too close to the moon. Now, nuking space rocks might sound over the top, but NASA actually has some experience with asteroid defense. Back in 2022, they pulled off something groundbreaking with their Double Asteroid Redirection Test, or DART. That mission was all about proving that humans could physically change an asteroid's path without using explosives. NASA launched a small spacecraft in November 2021, and after almost a year of travel, it crashed head-on into a tiny asteroid named Dimorphos at about 14,000 miles per hour. The idea was simple. If you hit an asteroid hard enough, you can slightly change its orbit, just enough to make it miss Earth someday. And it actually worked. The test showed that even a relatively small spacecraft could make a serious difference. Now, the European Space Agency wants to double-check exactly how much of an effect that crash had. In October 2024, they launched a follow-up spacecraft called Hera from Florida's Cape Canaveral Space Force Station. Hera is on a 2-year journey to reach Dimorphos and its bigger partner asteroid, Didymos. By October 2026, Hera will enter orbit around the asteroid pair and start collecting data, basically checking NASA's math. ESA scientists hope that once they analyze the impact site, they'll find out how effective DART was at changing the asteroid's trajectory. If it turns out that kinetic impact, aka smashing a spacecraft into an asteroid, works well enough, future missions might use that technique again. Maybe even for YR-4, if it ever becomes a real threat. But if it doesn't, that's when the nuclear backup plan might come off the shelf. Either way, scientists are making sure that if a space rock ever threatens Earth or the Moon, humanity will have more than just a Hollywood script to rely on. By the way, people at NASA run what-if asteroid exercises every 2 years to get scientists, state agencies, and international experts on the same page. During such asteroid drills, experts pretend that a giant space rock is heading our way. Then they work through all the tricky questions they can come up with, like how big is it, where might it hit, what should we do? It's like a massive brainstorming session to make sure that if this ever happens, we won't be starting from scratch. To make these scenarios feel as real as possible, NASA's Center for Near-Earth Object Studies gets involved. These are the folks who track real asteroids and calculate their orbits. So they simulate months of asteroid observations, complete with uncertainties about its size, trajectory, and potential impact zones. No one knows exactly how big the asteroid is or where it can hit. It's the kind of uncertainty that makes decision-making way harder, just like it would be in real life.
Well, guess what? Earth has not 1, but 7 moons. At least 7. There might be more. And this knowledge changes the whole picture of the world, doesn't it? Does it mean we're going to colonize not 1, but 7 space bodies and have 7 lunar bases? Will we have a choice on which natural satellite to spend our space vacation in the future? Well, here's the thing. These extra moons are kind of different. They're called mini-moons. Now, there's no official definition for a mini-moon because, of course, scientists can't agree on anything. But the general idea is it's a space rock that gets temporarily stuck in Earth's gravity, does at least one full loop around us, and at some point swings in pretty close, like within 4 moon distances close. Basically, if it gets close enough to freak out astronomers, it counts. Our Earth gets these tiny moons from time to time. They swing by, hang out for a bit, and then head out to orbit the Sun. Every now and then, chunks of space debris get caught by Earth's gravity and starts orbiting us for a while, just like they're crashing on our couch before hitting the road again, sort of cosmic speed dating. Scientists thought that most of these mini-moons came from the asteroid belt, a giant pile of space rubble between Mars and Jupiter. But some recent discoveries are kind of throwing a wrench in that. It turns out that some of these tiny moons might actually be pieces of our own moon. One famous example, back in 2016, a telescope in Hawaii spotted a weird little object hanging out near Earth. They named it Kame'o'olea, which to me sounds like a cool vacation spot. But it's really a 328-foot wide space rock that orbits the Sun in sync with us. Later studies showed it probably broke off the Moon between 1 and 10 million years ago, I wasn't around then, when something massive slammed into it and made the Giordano Bruno crater. And just recently, another object popped up, 2024 PT5. And guess what? It also looks a lot more like a piece of the Moon than your typical asteroid. Naturally, researchers couldn't resist running the math. One of them, Robert Jedicke, also known as the guy who's basically the mini-moon expert, and his team did several simulations to figure out how often moon chunks might end up orbiting Earth. Turns out, a lot of that debris can actually get caught by Earth's gravity, at least for a little while, and about 20% of it could become legit mini-moons. Now, the best guess is around 6 or 7 little lunar-born space pebbles might be orbiting Earth right now. Not forever, though. these guys have commitment issues. The average mini-moon sticks around for about 9 months before peacing out. And because new debris is always drifting into Earth's neighborhood, the squad keeps refreshing. But here's the thing. These numbers are super shaky. Jedicke literally said the uncertainty is ginormous, and I'm doing air quotes, which is the most sciencey way of saying, we're guessing here. There are just too many unknowns, like how big the moon explosions are, how fast the pieces fly, and whether our telescopes are even good enough to see the tiny stuff. So yeah, the prediction might be totally wrong, but that's science for you. You make a guess, someone proves you wrong later, and we all get smarter in the end. In any case, little mini-moons are super annoying to spot. They're usually the size of a car or an SUV, somewhere between 3 and 7 feet wide. It might sound big when you're parallel parking, but in space terms, that's basically a breadcrumb. But an even bigger problem is that they're tiny and fast. For us to see them, they have to swing pretty close to Earth so they reflect enough light. But when they're that close, they're also zipping across the sky like they're late for something, which makes them really tricky to catch even with fancy telescopes. That's one of the things that makes scientists worry about mini-moons. What if one of them eventually ends up in Earth's atmosphere? Then it could be the Chelyabinsk event number 2. You see, it was a quiet morning in Chelyabinsk until it wasn't. There was a flash of light so bright it outshone the sun, followed by a deafening sonic shock that rattled the skies and shattered reality, along with a few thousand windows. It happened on February 15, 2013. Without warning, a space rock the size of a house burst into Earth's atmosphere at over 11 miles per second. About 14 miles above the ground, it detonated mid-air, unleashing an immense amount of power. Glass rained down in homes, schools, offices. Over 1,600 people were injured, most of them by flying shards. And it wasn't even a big asteroid, just a cosmic pebble compared to the ones lurking out there. Luckily, according to Jedicke, modern sky surveys are surprisingly good at spotting stuff that small, even from millions of miles away. But there's a catch. These things move so fast they don't show up as dots in images like normal space objects. They leave streaks, and computers intensely dislike streaks. Those motion trails are harder for algorithms to recognize, so these tiny moons often just slip by unnoticed. Luckily, it's not all doom and gloom. The researchers point out that we did manage to spot one, 2020 CD3, even though it was only visible on 2 out of 1,000 possible nights. That's like finding a needle in a haystack while the haystack is spinning. But once we know where a mini-moon is, it's way easier to track it. And here's where things get exciting. Those tiny visitors might actually be useful. Since they come so close to Earth, they'd be way cheaper to reach than flying all the way to the asteroid belt. So space companies might one day try to snag one and mine it for minerals and stuff. Scientifically, mini-moons are also kind of a big deal. They could help us understand how the solar system was built and how it's still changing. Studying how chunks of the moon got blasted off and turned into orbiting debris might even help us figure out what kind of damage an asteroid could do to Earth. So yeah, these little guys may be fast, hard to find, and kind of flaky, but they've got loads of secrets to spill. By the way, Earth might have had 2 real moons once, and those were not mini-moons. One of them was our familiar one, and the other one was a smaller buddy moon tagging along. Sadly, things didn't end well for the little guy. Scientists have been wondering for years why one side of the moon, the one we always see, is smooth and flat, while the far side, the one that never shows its face, is all bumpy, crusty, and way thicker. Looks like the moon has a good side for selfies and a rough don't-take-my-picture side. So, according to a new computer model, that lopsidedness might be the result of a slow-motion cosmic fender bender. The theory goes like this. Millions of years ago, our moon had a smaller moon sibling cruising along with it in space. Everything was chill like for 80 million years. Both moons had the same vibes, similar makeup, same color, just one was 3 times bigger than the other. Then, gravity happened. As the moons drifted further from the Earth, the Sun's gravitational pull stepped in, messed with the smaller moon's path, and eventually sent it crashing into the far side of the bigger moon. This wasn't a huge action movie explosion. The speed was more like a slow but firm crash, not fast enough to melt rock, but just strong enough to squish one moon into the other like cosmic Play-Doh. The smaller one didn't leave a big crater. It basically smeared itself across the far side, leaving behind that mountain-heavy terrain we see today. After the crash, space got really messy. Trillions of tons of moon debris got thrown into orbit, and for a few days, the whole system was just dust, rocks, and chaos. And Earth? It got pelted with moon chunks for up to 1 million years afterwards. Some of those space rocks were the size of cities. So, in the end, our natural satellite may be a mix of two moons mashed together, one face smooth, one face forever marked by its lost twin. It's kind of tragic, kind of epic, and explains why the moon looks like it lost a fight on one side. So, you kind of forgot to duck, huh?
The moon might be hiding trillions of dollars worth of materials beneath that dusty surface, and NASA is about to get a piece of it soon. Their new lunar drilling tech just passed its first big test, and it could open up an entirely new frontier: space mining. This isn't just a scientific milestone. This could change the US economy forever, and maybe even reshape life on Earth. That's because they found something rare in lunar soil. Something that could become essential for us in the future: helium-3. Okay, so you know helium, right? It's the gas that makes birthday balloons float. Helium-3 is not that. It's a special isotope of helium, which basically means it has the same number of protons, 2 by the way, but a different number of neutrons. That's chemistry speak for it's rare, like super rare. Here comes the sad part. Earth had helium-3 once, a lot of it actually. But during our planet's formation, a lot of it escaped into space. Turns out, it's super light, so it didn't stick around. But we can still find it here and there, mostly inside our planet. I mean, there's some of it literally trapped underground. Or even a lot, as some recent studies might suggest. But still, the problem is that extracting helium-3 is expensive, limited, and seriously difficult. So difficult, in fact, that getting it from the moon suddenly sounds like a piece of cake. To really understand why extracting helium-3 in space might be easier, we need to quickly compare Earth and the moon. So here's the sun, right? This huge ball of fire in the sky constantly shoots out tons of helium-3. When this helium-3 reaches Earth, our planet's magnetic field acts like a giant invisible shield, basically saying, "Nope, not here," and it deflects most of it away. But the moon doesn't have a friendly protective magnetic field like Earth does. So when helium-3 reaches the moon, it hits the surface directly and gets trapped in the lunar regolith. I'm talking about that loose layer of dust, soil, and rocky debris covering the moon. And there might be tons of it, literally. Some estimates put it somewhere between 1 and 3 million tons of helium-3. The best part is that almost all of it is probably sitting right in the top layer of lunar soil. So instead of heavy-duty drilling, it could be as easy as just scooping up some moon dust. That's why a lot of people think getting helium-3 from our natural satellite could actually be way easier, or maybe even cheaper, than digging deep underground here on Earth. Now, you're probably thinking, why go through all that trouble? I mean, if it doesn't work for birthday balloons, what's the big deal with helium-3? Well, for starters, it's already being used in advanced medical tech, like magnetic resonance imaging and X-ray. But here's the real game changer. Helium-3 could actually end our dependence on fossil fuels for good. This rare isotope could be used for advanced nuclear fusion reactors here on Earth. In other words, it could give us nuclear energy that's not just super efficient, but a whole lot safer too. See, most nuclear power plants today run on a process called fission. They use uranium-235, and when those atoms split, you get a ton of energy. But you also get something else: radioactive waste. And yeah, it's just as dangerous as it sounds. But helium-3 is different. It could power future reactors with a process called fusion. If you mix helium-3 with a type of hydrogen called deuterium, you get a lot of energy, but without the dangerous waste. It could be cost-efficient too. Let's say a single space shuttle cargo bay could carry about 25 tons of helium-3. That would be enough to power the entire United States for a year. And scientists believe there's enough helium-3 on the moon to power the whole world for 10,000 years. These are only estimates for now, but the future potential is so exciting that the demand for helium-3 is already skyrocketing, and so is its value. In 2024, some experts say that the helium-3 market was worth about $670 million. This year, it's expected to hit around $730 million. And 10 years from now, experts believe it could reach nearly $1.6 billion. Sorry for all the numbers, I just wanted to show you why mining the moon matters. It might actually save us from a future energy crisis by giving us almost endless, clean nuclear power. Everything sounds great so far, but there's one big challenge. Mining helium-3 on the moon is one thing. Bringing it back to Earth is a whole different story. So let's look at one possible solution. First, robots or specialized machines would drill into the lunar soil or simply scoop up moon dust to collect the helium-3. Then it gets packed into containers and launched off the moon, heading for Earth. When the containers get close to Earth, a ship called the Space Rapid Transit will pick them up in orbit. Think of it as a reusable space truck with engines that can even use air for thrust. Finally, the ship would land at an airport here on Earth. From there, the helium-3 would head straight to power plants, giving us clean, safe, and almost unlimited energy. See how challenging it sounds, right? Of course, specialists are still figuring out the best way to transport helium-3. But one thing is certain, we're getting closer and closer to building a full mining base on the moon. NASA recently tested a new drill technology called Trident. And as soon as it touched the lunar surface, it started working right away and performed perfectly. For now, its main purpose is to bring soil to the surface so scientists can study it. They want to learn more about how strong the lunar regolith is and how it reacts when drilled. That's definitely an exciting step towards extraterrestrial mining. Because it's not just helium-3, you know. There are a lot of other valuable things that can be taken from the moon. For example, there's water ice on the moon, and from that, we could extract oxygen and hydrogen. Then there could be rare and expensive metals like platinum, rhodium, and iridium. We could even mine iron, silicon, and aluminum, which would be perfect for building things directly in orbit, like future space stations or other infrastructure. Now that we know how important mining the moon could be, you're probably wondering, is any of this even allowed? I mean, who actually owns the moon? The short answer? Nobody. Even though NASA is up there doing research, that doesn't mean the United States owns the moon. Back in 1967, some nations signed the Outer Space Treaty. It basically says no one can claim ownership over our natural satellite or any other celestial body. Not an asteroid, not a planet, not even a random rock floating out there. So, if a country wants to explore the moon, sure, they can do it, but they can't plant a flag and say, "This is ours now." Here's where it gets messy. Companies. There isn't much of an agreement about what private businesses can and can't do out there. For example, a private company sets up a moon base. They land a successful spacecraft, build a small station, and even start digging. The base itself belongs to them, sure, but the land they're sitting on does not. Everyone is on the same page up to that point. The tricky part is, the treaty doesn't really spell out what happens to the materials they dig up. Nobody is totally sure if those resources would even belong to them. And if the materials are not technically the company's, can they even sell them? It's hard to say. So yeah, sorry. Even if you had the cash to build your own lunar base, you probably can't just scoop up helium-3 and bring it back as a souvenir. I mean, unless you want to risk becoming the first person ever banned from the moon. You might think high-tech telescopes let us see every inch of the moon, but that's not true. At our satellite's south pole lie giant craters untouched by sunlight for eons, stuck in pitch black, colder than Pluto, and almost impossible to explore. However, maybe we have to if we want to explore space. Because the darkness hides some must-have resources that will make life and long-distance travel in space possible. Yes, we're talking about water locked up as tiny crystals in the lunar soil. Now, water in space is always good news. You've probably heard that scientists are also obsessed with finding it on Mars. If the red planet has any type of water below its surface, it raises the exciting possibility that life might have existed there. Even microbes would be the biggest discovery in human history. That's why rovers are poking around Martian craters and drilling into the soil like some very dedicated space gardeners. But as incredible as water on Mars would be, water on the Moon might be even more valuable to us in the short term. The reasons are simple: the distance and the gravity of the Moon. We can reach our satellite in 3 days. That's almost nothing. It takes at least 7 days to reach New York from London via a cruise ship. But more important than the length of the trip is the possibility of using the Moon as a pit stop. Stop, refuel, and relaunch so we can resume exploration. The gravity on the Moon is only 1/6 as strong as Earth's. That's not just useful for endlessly entertaining yourself by jumping around. This difference means that launching rockets from our satellite is much easier compared to launching them from Earth, which requires a tremendous amount of fuel just to break free from the atmosphere. For example, the Saturn V rocket, which took astronauts to the Moon during the Apollo missions, was made up of more than 90% fuel just to get off the ground. On the Moon, however, it's much easier to launch a rocket. That means that we could carry heavier loads with less fuel. It's like being able to take a bigger suitcase on your trip. If we can find and use ice on the Moon to create rocket fuel, it would turn our satellite into a practical and affordable stop for exploring the solar system. Not to mention that by applying some basic chemistry, we could extract oxygen from water and use it for breathing or rocket engines. Also, astronauts would need water to drink and grow crops on the lunar base. So, what do we know about the latest discoveries? For a long time, scientists thought the Moon was completely dry. But in 2009, NASA basically crashed a rocket into a crater. It caused an explosion of ice and vapor, like fireworks, and finally confirmed that the Moon had some kind of water. But how much? Well, enough to matter. The data suggests there could be hundreds of millions of tons of water ice locked up in the Moon's polar regions. Some estimates roughly say 1.3 trillion pounds. That's about the same weight as 460 million cars. Not exactly lakes, but still a lot. And there still could be more. This water could also contribute to uncovering cool scientific secrets. The ice is ancient, which makes it like a time capsule from the early days of the solar system. Studying those frozen molecules might tell us not only how water got to the Moon, but also how it appeared on Earth. Anyway, what's all that water doing on the Moon? How did it get there? Scientists assume that some of it probably hitched a ride on comets and asteroids billions of years ago. Many of those space rocks carried ice, and some of that water ended up in the polar regions. Another source could be the way solar wind interacts with the lunar surface. In any case, however this ice appeared on the Moon, the real trick is where it ended up, inside its polar craters. And while we can find the ice not only in the craters at the South Pole, that's where the largest, most stable reserves are believed to be. Some of those craters are enormous. One of the most famous is called the Shackleton crater, and it's over 13 miles wide and more than 2 miles deep. That's almost twice as deep as the Grand Canyon. The Moon barely tilts on its axis, only about 1 degree, so the sun never peeks over the rims of those deep polar pits. The temperatures dip to around -400 degrees Fahrenheit there. Any water or chemicals trapped in that frozen dirt just stay there, locked away like in a freezer. Something really cool is that at the South Pole, you have parts that are stuck in the perpetual darkness. but some nearby mountain ridges get almost non-stop sunlight. Scientists call them the peaks of eternal light. They are perfect for setting up solar panels, while still being close enough to access the icy treasures hidden below. The poles of the moon are the only places in our solar system we know of where perpetual day and night exist side by side. But the eternal night isn't just fascinating, it's dangerous. The terrain out there is absolutely unforgiving. We can't even simulate something like that on Earth. We don't even know what it looks like from the inside. It's worse than exploring the northernmost part of Antarctica while wearing a blindfold. So now that we know this, is that potential water even obtainable? That question is probably worth several trillions of dollars. Yes, there's water over there, but getting to it won't be like scooping ice cream from a bowl. What we're really talking about are microscopic ice crystals mixed into lunar dust. To make use of it, machines would need to dig and heat up the soil, then capture the vapor before it escapes back into space. And then there's freezing. Even assuming a human or rover could safely reach the bottom of a crater, it'd be almost impossible to navigate. Batteries and equipment probably wouldn't last, and it's impossible to use solar panels or electronics down there. They'd freeze in minutes. However, NASA's Lunar Reconnaissance Orbiter uses all kinds of radars and sensors to sniff out what the crater looks like inside. And now there's an even sharper tool, shadow cam. A camera so sensitive it can capture details in light 100 times dimmer than what our eyes can see. Basically, the ultimate night vision device. With it, we can finally map those pits without even setting foot there. That's why engineers are thinking up all sorts of clever solutions. Some concepts involve nuclear-powered rovers with headlights strong enough to carve through the dark. Others want robots that rappel down crater walls or hop across the floor like pogo sticks. There are even ideas for drills that could melt frozen soil and trap water vapor like condensation on a cold soda can. The silver lining is that this water isn't going anywhere. Until we improve our technology, the supply will wait for us. That being said, space agencies are already making advancements. In fact, more than half a dozen new missions are lined up over the next few years. NASA's Artemis program is getting ready to send astronauts back around the moon and then down to the South Pole. China's Chang'e 7 is planning to check out those dark craters. And private companies like Firefly and Blue Origin are gearing up to deliver equipment and experiments. Now, here's a bonus, lesser-known fun fact. The moon smells. When Apollo astronauts brought lunar dust into their landers, it mixed with the oxygen inside and ended up smelling pretty strong. They said it was like burnt gunpowder or fireworks. Lunar dust has nothing to do with gunpowder, but its particles are highly reactive. After sitting in space for billions of years, they reacted instantly with oxygen in the cabin, creating that smoky odor. Future explorers are definitely going to notice that smell too, since lunar dust tends to stick to everything. Let's hope that, aside from everything else, scientists will work out air fresheners for the moon base.